So we've talked about the side-side-side theorem. Now we're going to talk about the side-angle-side theorem. The first thing we want to describe is what an included angle is. An included angle typically would be, let's look at this figure for a second and answer the questions for that, and that will help us in answering this one. It says, what is the included side of angle 1 and angle 3? So angle 1 and angle 3, they're asking us for the included side. Well, the included side will be this one right here, which is located right there next to the angles that they're asking. Angle 1 and angle 3. And then the included side, when they ask us for the included side, what is the included, well, we just answered is the included side. So when they say what is the included angle for DF and EF, so DF and EF, they meet right there. So the included angle will be angle 2. So make sure you understand what they mean by an included angle, which is found when two lines like that meet right there, and the included side when two angles are mentioned, the side that is that corresponds to those angles. When we come over here and they ask us to write the congruent statements for these two triangles, what we need to understand is that AC is congruent to DF. Notice that the side is marked. I know that my triangles are not perfect ratios here, but you need to understand this is congruent to this, and I'm explaining why. This side is congruent to that side, and this side is congruent to this side. This angle is congruent to that angle, so we'll say that these two angles are congruent to one another. That's what lesson 28 talks about. The fact that two sides and one angle of one triangle are equal to the two sides and one angle of the other triangle, and hence we can say that they are congruent. Here it's asking if these two triangles are congruent using the side-angle-side theorem. Again, we notice that this side and this side are equal, that angle, and we know this side and this side are equal, and we would say that they are congruent to one another. This is not drawn to scale, but again, you get the idea. Side, angle, side. Now let's do a practical problem with this theorem. Let's use this theorem to solve a problem. In your textbook, it gives an example of trying to find an angle, or where, you know, they give you two linear, like 2x plus something for one angle, and then 3x plus something for another angle, where you just put them equal to one another and solve. Let's go ahead and do it for this one right here. When they say 9x minus 11 is the length of one side, and 3x plus 4 is the length of the other side, well, first of all, we acknowledge that this angle and that angle are equal, and this side and that side are equal. And so what we have now is that this side is supposed to be equal to that side, and so they can ask you to solve for the length of, what is x? So you find the length. And so you go ahead and equate 9x minus 11 with 3 over 2x plus 4. And you just go ahead and solve that using the basic principles of math. You go ahead and subtract 4 from both sides so that you can get this by itself. So you get 9x minus 15 is equal to 3 over 2x. We're trying to bring like terms together. And so with the x's, if we want to get rid of the 2 on the bottom, we can multiply both sides by 2. And that way we get rid of the 2 on the bottom. And so we have 18x minus 30 is equal to 3x. We go ahead and bring the 3x to one side, to the same side with the 18x. And so we have 15x is equal to 30 and x is equal to 2. So that's how we solve a problem that has to do with the side-angle-side theorem. So make sure you bring your questions if you have any questions. But if not, this is a basic example using the theorem that we just learned from lesson 28.